Hello, welcome back to our series on Kubernetes for beginners. If you are new to this channel, we simplify Kubernetes concepts into small, easy to understand chunks. Be sure to check out our other videos where we explain a variety of Kubernetes concepts. In the last video, we discussed about various deployment strategies and which strategy you need to use as per requirements. In this video, we are going to break down an important topic in Kubernetes, that is namespaces. We break down what they are, why they are important, and how you can use them to organize and manage resources efficiently. So, let's dive in. Let's start with the basic. A namespace is like a virtual cluster inside your main cluster. It's a way to group resources together and create boundaries between different set of objects within the same cluster. Kubernetes uses namespace to provide a scope for names, which means you can have objects with the same name in different namespaces without conflict. Imagine you have two Nginx pods, both named Nginx. You are running them in the same cluster, but one is for your production environment and other is for your development environment. Since both pods share the same name and are in the same cluster, it becomes tricky to manage them. For example, if you want to update or delete the pod in development environment, it would be hard to tell which pod belongs to which environment because of the identical names. This is where namespaces comes in. By creating two separate namespaces, one for development, let's say dev namespace, and another for production, say a production namespace, you can keep the pods organized. The dev pod will exist in the dev namespace and the production pod will be in the production namespace, making it easy to distinguish and manage them separately. We got the namespaces are important, but how was we able to create deployments, pods, replica sets till now? Well, the answer is Kubernetes have some namespaces created itself when you set up the cluster. So let's look into what are the default namespaces in Kubernetes. Kubernetes comes with a predefined namespaces, and these are important to know, especially if you are getting started. So let's break them down. First is the default. The default namespace is where all your components will go if you don't explicitly specify any other namespace. We have also experienced this. Till now, when we created pods, deployments, replica sets, it all went into a default namespace as we have not defined namespace explicitly. Then we have kube-system. This one is for all the core components of Kubernetes like the API server, scheduler, and controller manager. Unless you're diving into Kubernetes, you generally won't interact with this namespace. I would recommend that as a beginner or unless you know what you're doing, do not touch on this namespace. Then we have the kube-public. The kube-public namespace is an interesting one. It's readable by everyone, even unauthenticated users, and is typically used for cluster-wide public information. Like if you want to get the cluster information, you can get this in the kube-public namespace. Then we have kube node lease, which is newly added. This namespace is used to improve node scalability and performance. It contains lease objects that are associated with each node. Kubernetes uses these objects to determine the health and status of nodes in the cluster. These are namespaces Kubernetes created by default, but you can always add your own, and we will see how to achieve that in the later part of this video. But first, we need to understand why would you want to use namespace in the first place? Well, there are several key reasons for that. First is isolation. One of the main reasons to use namespace is to isolate resources. Let's say you are running multiple environments, development, staging, and production in the same Kubernetes cluster. You don't want resources from one environment accidentally interacting with those in another namespace. Namespace provides that isolation. So if you put all these pods for dev, testing, and production in the default namespace, they are going to interact with each other and you will not have any control. Then for resource management, Namespaces allows you to allocate specific resources to a different teams or environments. You can use resource quotas to limit how much CPU, memory, or storage a particular namespace can use, ensuring fair distribution of resources. For example, like in dev environment, you don't want a lot of CPU or memory or storage, so you will assign a bit less amount of CPU memory to dev environment. While for production, you might need more. Then we have access control. Namespace also plays a key role in Kubernetes security. Using role-based access control (RBAC), you can restrict what users or service accounts can do within each namespace. For example, you might give your DevOps team full access to the dev namespace, but only read access to the production namespace. Organizing microservices. If you're working with microservices architecture, it's a good idea to organize your services by namespace. For example, you might have a front-end namespace and a back-end namespace to keep things tidy. What are the different use cases for namespaces? First is multi-tenancy. If you are working for a large organization or hosting multiple applications in the same cluster, namespace allow you to create virtual boundaries for each tenant or team. Each team can get its own namespace where their resources are isolated from others. This is called multi-tenancy. Another common use case is environment separation that we have already seen. You can create namespace for dev, staging, and production environment so the components in each environment don't accidentally affect the others. Then for resource quota, to manage your cluster's resources effectively, namespaces allow you to assign resource quotas. You can limit the amount of CPU, memory, and other resources that each namespace can consume, ensuring that no single application hogs all the resources. And in CI/CD pipelines, namespaces are often used to create temporary environments for testing and then tear them down once testing is completed. This helps ensure that test runs in isolation from other parts of the system. Now, how to organize components in namespaces? Organization is the key to managing a large Kubernetes cluster. Let's look at some way you can organize your components using namespaces. First is group by application. For smaller setups, you can organize components like ports, services, config maps, and secrets together in the same namespace if they belong to the same application. For instance, you can have a backend namespace for all the backend services and a front-end namespace for the front-end services. Then group by team or department. In larger organizations, namespaces are often grouped by team or department. This allows different teams to manage their own resources without worrying about what other teams are doing. Each team can have their own namespace like team A, team B, and so on. Then environment specific namespace. You can create separate namespace for different environments. We have already seen like dev, staging, and prod to ensure resources from one environment don't interact with others. Now let's see how to set access and resource limits in namespaces. One of the biggest advantages of namespace is the ability to set limits on resource usage and control access. Let's go over how to do that. In Kubernetes, resource quotas help control the resources like CPU, memory, etc. within a specific namespace. They ensure that a single team or application doesn't consume all the resources in a cluster, leaving none for others. Think of them as a limits you can set on how much total compute power or memory can be used by all the ports or containers in that namespace. Here is a breakdown of how resource quota works. So first, why use resource quotas? In a shared environment, like in an organization where multiple teams use the same cluster, you don't want one team or application to hog all the resources. By applying quotas, you can distribute resources fairly and prevent overuse. What can you limit using resource quotas? First is CPU. You can limit how much processing power a namespace can use. Then you can limit memory. You can set limits on the memory usage. Then you can also set or control the storage. You can control how much disk space it can be used. And then the number of objects. You can also limit the number of resources like ports, services, config maps, etc. in a namespace. How does it work? Each namespace can have a resource quota object, which defines the upper limit for resources within the namespace. When a pod is created, a resource is requested. Kubernetes checks if it fits within the defined quota. If it exceeds the quota, the Kubernetes will deny the request. Let's look at an example. Let's say you have a namespace for the dev environment. You want the limit its usage to, like 2 CPUs or 4 GB of memory. You define a resource quota like this. You will create a resource quota.yaml file, and like any other YAML file, it will have the API version, which is v1. The kind will be resource quota, and the metadata you provide name to this resource quota. So I'll call it dev quota. And in the namespace, you have to provide the namespace which you want to control using this resource quota. So you will call it as dev. And in the specification part, you have to provide these values. So you have to type in hard, that is for the hardware, and request.cpu equals to 2, request.memory equals to 4. And similarly, you have to set the limits. So limits.cpu equals to 2 and limits.memory equals to 4. Now all pods in the dev namespace combined can only request and use up to 2 CPUs and 4 GB of memory. So what are the benefits? It will prevent over allocation, ensure fair resource usage across all teams or applications. Then the cost control, help manage resources efficiently in the cloud environment where resources are built. Then the cluster stability, it avoids resource exhaustion, which can lead to failures in the cluster. In short, resource quotas allows you to control how resources are shared in a Kubernetes cluster, ensuring efficient and fair usage across multiple teams or applications. Another thing that we can use namespaces is for RBAC, that is role-based access control. You can also define who has access to which resources within a namespace using RBAC. You can assign roles to users or service accounts at the namespace level, ensuring that only certain people or services have access to sensitive resources. For example, you don't want DevOps teams to have access on the production environment, or you do not want testing team to have access on the development environment. So you can control it using RBAC. We will have a separate video on RBAC as it is a bigger topic. How to create components in namespaces. Now we have seen like, okay, we will create a namespace, we can create resource quotas, but how we can introduce this namespace to the pods or deployments. So creating components like pods, deployment or services in a specific namespace is very straightforward. Just specify the namespace field in your YAML manifest file. So I'll open up pod definition file that we created earlier. We'll just add another field under the metadata section, that is namespace is dev. So this will mean that this particular pod will be created in the dev namespace. If we change it to prod, it will create under the prod namespace. And if you don't specify explicitly, then it will go under the default namespace. Alternatively, you can create a namespace in Kubernetes by simply running the command kubectl create namespace. This command creates an isolated workspace within the cluster for your resources. Or while creating a component, you can specify the namespace directly in the kubectl command by using the ---- namespace flag. For example, kubectl create f pod.yaml. So this file will be used for creating the pod, and here you can add ---- namespace equals to dev, and this will say that this pod will be created under the namespace dev. If you forget to specify a namespace, Kubernetes will create the component in the default namespace. Now to get list of all pods, I will use the command kubectl get pods, but as you can see, nothing comes up because we created pods in a separate namespace, remember? So we have to use a command ---- or a flag like -n. So we'll type kubectl get pods -n dev, and now we can see pods created in the dev namespace. Similarly, we can do for production pods by simply typing kubectl get pods -n prod. Now we can see the production pods. What if you don't want to explicitly specify the namespace? For example, you're mostly going to work on dev namespace and you will only see pods in the production namespace as and when required. Well, You can use this command to change the active namespace for your cluster. So you will use kubectl config set context --current and --namespace equals to dev. This command switches your current context to the dev environment namespace. So any future commands you run will affect resources within the namespace. For example, if I type kubectl get ports now, I'll get the dev namespace port. But if I want port from production, then I have to specify -n prod. There are a few tricks and tips for working with the namespaces. Avoid using the default namespace for important applications. Instead, create dedicated namespace to keep everything organized. Keep the system namespace like kube-system intact to ensure the cluster runs smoothly. So I'll suggest don't touch kube-system namespace. If you're dealing with shared resources, keep them in a separate namespace that's accessible by multiple namespaces like shared services or infrastructure. Use labels and annotation in your YAML file to further organize resources within a namespace. Remember, we were using labels in the while we're creating the ports or deployments. So with the combination of labels and namespace, we can better classify our resources. This is essentially useful if you have a lot of components in a single namespace. And that's everything you need to know about namespace in Kubernetes. We covered what they are useful, and how to manage resources across different namespaces. Namespaces are a powerful tool to keep your Kubernetes cluster organized, so make sure to use them effectively. If you find this video helpful, don't forget to like, share and subscribe to the Data Donuts. Drop your questions in the comments below and I'll be happy to answer them. Until next time, keep building awesome things with Kubernetes.